Hello everyone, in this video I will show you the new procedural particle system version 2.0. It has many new features, new forces nodes and easy workflow. In this video I will show you how to make these effects with this particle system. Let's get started. You can get this particle system from my Gumroad page or from the Blender market. However, if you have the paid version of extra nodes, you will get the free update for this particle system. So when you download this, you will get this blend file. When you open this file, you will have this particle system. So there are two ways to use this particle system in your project file. You can use this as assets, or you can append this particle system into your project files or in different blend files. So to use this as asset, first you have to copy this blend file into your asset folder. And after that you have to specify the path for that asset folder here. And now if I open a new file and then go to the asset browser, then go to this unassigned category, and from here you can add this particle system. Okay, let me go to this geometry nodes. You have these node setup and you have this particle system. Or you can append that particle system. Just go to the append and then navigate on this blend file and then go to the object, then append this object into your blend file. It will append this particle system setup object and as well as this default emitter object into your scene. So now I will explain the settings of this particle system. So this is the overview of this node setup. So first you have this input geometry and points. Basically you have to input the emitter geometry, or you can directly input the points for the particles. After that you have this simulation input and particle system input section, which is this one. Let me hide these things. And after that you have this force section, and then you have this particle system output and simulation output section. In the end you have this particles object and material section. Okay, and these are the forces nodes and these are the utility nodes for the particles. So let's focus on this section. When you append this or use this as assets, first you have to input the emitter geometry. You can change the emitter from this modifier panel, or you can directly input the geometry here in this socket. Okay, so it has three sections for the settings. First is the simulation settings, then you have this emitter settings, and in the end you have this particle setting. Okay, in the simulation setting you have to define the frame range for the simulations of the particles, and you have to also define this time step. Most of these settings have these tooltips. If you place a cursor on the input, it will show that tooltip. After that you have these emitter settings. First you have to choose between these emission types, whether it is start and frame based or continuous. So start and frame is similar to the existing particle system. Like in this case we have this start and end frame for the emission. And if you use continuous, then it will continuously emit the particles from this geometry or points you have added into this node. So let me show you this. Right now it is using this frame based. Let types here 50 frames. So it's going to emit the particles between these frames. See, after the 50th frame, the particle emission gets stopped. All the particles are emitted in this frame range. Another thing is that these frame ranges are independent from each other. Okay. And if you use continuous, let me decrease this particle density, then it's going to emit the particles continuously from this emitter object. See, because it is continuous, we can decrease or change this particle density as the simulation is running. Let me decrease the number of particles because I am recording. Here you can basically change the particle seed and choose the between the emitter geometry or the points. Right now we are using this emitter geometry for these particles. Let me put this as the points, and if we change this to points, it's going to use the number of vertices of this input mesh for the particles. You can also use your own distribute points for the particles. Let me increase this to 500. Okay, now this is very nice feature because we are using the geometry for the points, and if we directly connect this to this, you will see that, let me go to the first frame. See, it is emitting the geometry of this emitter object as time progress. So that's why it is very nice feature. You can directly emit the geometry instead of the particles. Let me connect this back to this. After that, you have this particle settings. So basically you have all these attributes that are related to the particles like life, size, mass, color, velocity or normal velocity, velocity based on the normal of this emitter, geometry or the points normal. Then you have this emitter velocity. Like in this case, this emitter is animated, and if you want to add that velocity to the particles, you have to specify the UV map of this emitter object and then enable this emitter velocity, and after that you can control the strength of that velocity for the particles, and then you have this rotation for the particles. And all these settings are field based, so you can use different field to control the values for these attributes. Like in this case, I'm using this random node to define the random life for different particles, and also random node to control this emitter velocity. So when this continuous option is enabled, all the settings are dynamic. You can change while the simulation is running. Okay. So after this, you have this particle system output and simulation output zone. I'll talk about later about these forces. So it has few settings. The first is mesh surface. This option will allow you to project these particles onto any surface. So let's add a icosphere. Let me make this slightly big and then bring this here, and let me add this here, and after that you have to basically enable this. See all the particles on this mesh surface. Let's add 120. Another important thing is that this option is field based, so you can use a different field to control the particle projection for this object. Like if I add this noise texture, and let's also add this greater than node. So let's add maybe a 0.5. See, some of the particles are onto this surface. The second option is to keep these particles inside or outside the mesh volume. First you have to enable this mesh volume, and if we go to the first frame, see all the particles are inside this icosphere. If I move this icosphere side to this particle system and enable this outside option, see, it is keeping all these particles are outside from this icosphere. So these are really important features. If you want to keep the particles outside from a certain volume, keep in mind that for this volume, the mesh should be closed. It doesn't work for the open mesh. And after this, you have this particle object and material section. By default, this keep all the particles whether they are born, whether they are alive, or whether they are dead. It keeps all the particles. So this particle info node allow you to select between different particles. Like these are the, let me run the simulations. These are the born particles, these are the alive particles, and these are the dead particles. Because different effects need different kind of particles. That's why I have keep all the particles inside this simulation zone. And this node provide all the attributes for the particles like index, born time, age, life, size, mass, color, position, velocity, rotation, and random. So you can use these attributes to control the behavior of the particles inside the simulation zone or outside the simulation zone. For these attributes, if you go to this modifier panel and enable this internal dependencies, you have all these names for these attributes. You can also see these names inside this node. So you can use these names to get these attributes inside the shader nodes. Like in this case, I'm using the age of the particles to control the colors for these particles. Let me make this alive. And if I go to the material preview, you will see this. See how these colors of these particles are changing with their age. So these are the basic settings for this particle system, and you have these 17 forces nodes to control the behavior of this particle system. Basically, you have to add these forces here in between the system input node and particle system output node. Okay. However, if you don't find a force inside these forces node, you can construct your own force. So basically you have to duplicate this node. Let me duplicate this node and plug that inside this force zone, and here you have to input your force, and you have also option to consider the mass, means whether your force is depends on the mass of the particle or not. So in this way you can add your own force to the particle system. Okay, so these are the particle utility nodes. I have already explained this particle info node. You have this set particle attribute node and particle tracer node. Let me add this particle tracer node. Let's duplicate this and then add that to this geometry, and let's go to the first frame. See, it is tracing the path of the particles, and you can also combine this with the particles. Okay, now you have the path as well as the particles. This tracer node work for all the modes, whether they are frame range based or continuous, or whether you are using the meter geometry or the points. Okay, then you have this the set particle attribute node. Let me duplicate this node. So you have to connect this node here, basically in the force zone, and here you can change any of these attributes like size, mass, color, position, velocity, and rotation. So let's change this size, and let me connect this size to here. Now let's go to the first frame. So here we can basically change the scale for these particles. Let me change this to 120 frame. So it will emit the particle from first to 120th frame. See, we can change the scale of these or size of these particles, and again these inputs are field based, so you can use the field to control these inputs. Let's add a greater than node and then change this to a float, and I'm going to use the fall of nodes. These nodes are freely available on my Gumroad page. Okay, so let's add this, connect to this, and we're going to use empty object. Let me pin this first, and let's move this here, and now you will see that we are changing the size of these particles. Oh, this is outside. Let's bring this empty here. See, in this way you can control the basically any of the attributes based on the field. Okay, basically color, mass, any of these attributes. I'll show you a special force, that is the kill force. Basically it's going to kill the particles based on this field threshold. So let's add again this fall off node. Let me select this empty and connect this to this. It's going to kill the particles that is satisfying this threshold for the field. Okay, if I type means 0.75, see, more of the particles are going to this empty. If I type 0, it is basically killing the particles which is satisfying this threshold. So this is really useful, especially if you want to kill the particle if they are enter into certain zone. You can use this node. Okay, so there are different type of forces like a particle interaction force. You have the collision force when the particles are colliding with the different mesh objects. You have curl gradient force. All these type of forces are here. So now I will show you how to make this Doctor Strange particle effect with this. So the first thing is that we have this emitter object which is animated about it is a y-axis, and then I have used these settings. Basically I randomize the life of these particles, and I am using this emitter velocity or velocity from this animated emitter for these particles. Let me increase the counts for these particles. So we have this, and then I'm using this turbulence force to add structures to this particle. So let me mute this. See, they are mostly uniform. If we enable this, it's going to add some kind of structures or clumps to these particles. So we have this basic setup, and after that here we're going to delete this icosphere and we're going to add this C line, a curve line, and let me hide this, and then we're going to use the velocity to align this line along the velocity direction of the particles. And let me disconnect this, and then we're going to use the velocity to control the basically the size of these particles. Let's add the multiply node here, and after that we're going to add the values to this. So let's make this 0. This is like a constant value for this size, and this is going to be the velocity based value. So you have this, and then we're going to convert this curve or line into a mesh, C to mesh. So let's connect to this, and then we're going to add a circle for this. Make this 6 and this to be 0.1, maybe 0.1, yeah, maybe 0.05, 0.005. See, you have this, and if we go to this rendered view, let me make the strength of sky 0. You have this Doctor Strange particle effect. So you can add more variations to this, means more number of particles and different size, like random size. You can add this random node here, and let's make this size around 0.1 to 0.35. So you have this random scale for these particles. And you can also add more variations to this, to the color of these particles, okay, based on these attributes of the particles. So this is the basic setup for Doctor Strange effect. You have input node, one force, only the turbulence force, and then output section, and so this is the particles, object and material section. And now suppose you want these particles to collide with the floor. So let's add a cube, scale this, and then move this down, something like this. And let's bring this cube here. And then we're going to add this collision force. Let's duplicate that and then add that here. So now we have added this collision geometry. So if we go to the first frame, see these particles are colliding with this cube, and let me change this to a -1. So the start of the line is the location of the point. Yeah, we have to make this -1, and because some of the points are going inside this cube. You can use this for this mesh volume and enable this and keep this outside. Then it will then no particle will go inside this cube. So in this way you can add this collision force to this particle system. So this is the setup for this Doctor Strange particle effect. Now suppose you want to add a more number of particle system into your scene. Just make a group and you have this particle system, and let's bring some of the main settings outside, maybe a seed, a particle seed and particle density, and maybe this velocity scale. And let's duplicate this one and then join these together. Here we can change the seed, maybe decrease the number of particles and increase this velocity scale. So let me hide. So these are the particles from this particle system and these are the particles from this particle system. So in this way easily you have these two particle system for this same object. In this way you can add as many particle system as you like, okay, and keep some of the main settings outside that you want different from each of this particle system. Now I will show you how to scatter these particles smoothly onto a surface that I showed in this video. So let's make that. That is also very easy with this particle system. So now we have this fresh file. So first thing we have to add the text. So let's add the text. Let's rotate this, and then we're going to add the geometry onto which we want to disperse these particles. So let's use this icosphere, which is simplest. However, you can use any geometry you want. Make this 3, and now it has these 3 level of subdivisions so that we have this uniform surface. First thing we have to change is that we have to make this text as emitter, and then we're going to make this start or end frame 1 so that all the particles are born on the first frame. I'm going to delete this node as well as this node that is not needed, and increase the life of this to 120 frame. Let me check this. Yeah, it's working. Let's decrease the number of particles, maybe 2000, 20,000. This is particle density, okay. This is not the number of particles, okay. Yeah, it is fine. Let me delete this circle. So let's bring this icosphere here, and then we're going to plug this into the mesh surface and enable this mesh surface. Now see, all these particles are moving onto this icosphere. Let's move this emitter close to this icosphere, maybe small in size. Yeah, it is working fine. So now basically we have to control the strength of this turbulence force, and we have to also add this particle force node. So let's make some room for that, and then we're going to duplicate this one. By the way, why I'm duplicating these nodes instead of directly using them? Because right now they are using this fake user. If I accidentally disable this and delete this node, then it will be deleted from this blend file if I basically reopen that this blend file. So that's why I'm duplicating these nodes. So now let's see, it is working. Basically we have to decrease this strength of this noise. Let me hide this text. Yeah, it's working. So now basically we have to control this noise strength based on the age of the particles. So let's duplicate this node, this particle info node, and then we're going to add the map range node. We're going to define the range for this age, maybe of 50. So when the age become 50, this value for the strength become from 0 to 0.2. And let me hide other outputs. Yeah, it looks nice. Let me decrease this on this particle force strength. One thing I would like to mention is that most of the forces have these strength from minus to plus values. Okay, like in this case we are using plus values, means this force is repulsive. If you use negative value, then this force become attractive, and this is also true for the other forces, like in this case of curve force, central force and mesh force. It is also true for other forces as well. Okay, so now we have this, and if we go to the material preview, let me go to this render view and also hide this icosphere. We have this effect. Now let's add the different colors based on these letters. So these letters are basically a different mesh islands. So we have to capture a random values per island of this text. Change this to a face and then add the mesh island node. Then add the random node. Connect this to the ID. Change this to float and then connect to this. It will add a random value to each of this letter of this text. So we're going to use this random value to control the color for the particles. So let's use this for the color of the particles. Now we have to go to this shader node. Let's go to this, and instead of this we're going to use the color. Let's also add a new color ramp node. Then I'm going to reset this color ramp, and let's change this to a constant. So this may be a red, orange color. Now let's go to this material preview and let's change this seed. Oh, this looks cool. Maybe I have to decrease the radius of this icosphere. Yeah. So this is the main setup for this particle disperse effect. This is the basically a material for this. See, it is very simple to create this kind of effects with this particle system. This is it, and if you want more tutorial about this particle system, please let me know. Or if you have any query related to this particle system, please also let me know in the comment sections, or you can directly ask me on my Discord channel. If you like this work, then please do support me. You can buy my presets, or you can support me through my Patreon page. So until next time, happy noding, bye.